Today we are going to be talking about the unit circle. By the end of this video, you should be able to label the special angles of the unit circle in both degrees and radians, and you should be able to label all trigonometric functions on the unit circle. So first, let's take a look at this circle that we've drawn that has a triangle inside of it. The unit circle has a radius of 1. So on this circle, the radius would be 1. If we look at the triangle inside the circle, that means that the hypotenuse of this triangle is 1. If we are looking at an angle, theta, and we have this point that is on the circle, this point has coordinates x, y. If we tried to write that point in terms of our angle theta, we could use SOHCAHTOA to find that the x coordinate would be cosine of theta equals this side, our x side, over 1. So cosine of theta is equal to x. Similarly, if we use SOHCAHTOA, we would have sine of theta equals y over 1. So our y value is going to be sine of theta. Now, let's go ahead and zoom in on this triangle. We have that the hypotenuse is 1. This is our angle theta. We have sides that are x and y. If we decide to make this a little bit more general, we could have this hypotenuse be r. So sine of theta would be y over r. Cosine of theta would be x over r. And tangent of theta would be y over x. All I'm doing to get these values is use SOHCAHTOA. Then we have our reciprocal functions, which you may or may not be familiar with. Cosecant of theta is 1 over sine of theta, which means that that would be r over y. Secant of theta is equal to 1 over cosine theta, which is r over x. Then cotangent of theta is 1 over tangent theta, which would be x over y. So these are our 6 trigonometric functions. If we go back to geometry and look at 2 special right triangles, first we have 30, 60, 90 triangles. If we make the hypotenuse equal to 1, then by our special triangle rules from geometry, we know that the short leg is going to be half of the hypotenuse, which is 1/2, and the long leg is going to be square root of 3 times the short leg, so square root of 3 over 2. Our other special right triangle is a 45, 45, 90 triangle. If we let the hypotenuse be 1, then from our special right triangle rules, we know that the legs will be the hypotenuse divided by square root of 2. If we go ahead and rationalize this, we multiply by square root of 2 over square root of 2, and we get square root of 2 over 2. So that means that both of these legs have length square root of 2 over 2. Now, the reason that we are looking at these 2 special right triangles is because we are going to use these for the unit circle. So here is our unit circle. We want to look first at the angles. We mentioned in a previous video that when you are measuring angles, your initial side is always the positive x-axis. So here, this is going to be 0 degrees, or 0 pi radians, which is just 0. The coordinate of this point, if we are assuming that the radius is 1, would be the point 1, 0. We also mentioned in a previous video that going all the way around the circle is 360 degrees, or 2 pi radians. So this angle is the same as 360 degrees, or 2 pi radians. Since we know that 2 pi radians, or 360 degrees, is a full rotation around the circle, that means that going halfway around the circle is 180 degrees, or pi radians. This point would have coordinates -1, 0. Going a quarter of the way around the circle would be 90 degrees, and that would be pi over 2 radians, because it is half of 180 degrees, or pi radians. The coordinates for this point is 0, 1. If we go 3/4 of the way around the circle, that's 270 degrees, which is 3 pi over 2 radians. The coordinate for this point would be 0, -1. This first angle here in the first quadrant is going to be 30 degrees. The third angle in the first quadrant is 60 degrees. "30 degrees is a third of 90 degrees, so this is pi over 6 radians, and this is pi over 3 radians. If we continue counting by 30 degrees, we would have 90 degrees, then 120 degrees, then 150 degrees. 120 degrees is going to be 2 pi over 3 radians. 150 degrees is 5 pi over 6 radians. And all I'm doing to get those values is multiplying 30 degrees or 60 degrees. If we continue going around the circle, counting by 30 degrees, the next one is 210 degrees, which is 7 pi over 6 radians. Then 240 degrees, which is 4 pi over 3 radians. Then we get to 270 degrees, which we already did. The next one would be 300 degrees, which is 5 pi over 3 radians. Then 330 degrees, which is 11 pi over 6 radians. Now, the angles that I have skipped are all multiples of 45 degrees. So 45 degrees is half of 90 degrees. So in radians, this is going to be pi over 4. This angle in the second quadrant is 135 degrees, which is 3 pi over 4 radians. The next one is 225 degrees, which is 5 pi over 4 radians. And the last one is 315 degrees, which is 7 pi over 4 radians. So these are all of the special angles on the unit circle. They are all multiples of 30 or 45 degrees. Now let's take a look at the trig functions for these angles. So we have the same setup. we know that the radius of this circle is 1. So this point here is going to be 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. Now we're going to write the coordinates for all of the other angles, the multiples of 30 degrees and 45 degrees. As we mentioned earlier, the coordinate point is going to be cosine theta, sine theta, instead of x, y. So this first angle was 30 degrees. So if we think about our 30, 60, 90 triangle, we know that the short side is going to be 1/2, and the long leg is going to be square root of 3 over 2. So that means that our x value is square root of 3 over 2, and our y value is 1/2. If we skip to the 60-degree angle, this is also a 30, 60, 90 triangle. The short leg is 1/2, which in this case is the x coordinate. The long leg is square root of 3 over 2, which is the y coordinate. So we're going to continue around the unit circle looking at the multiples of 30. So our next angle, if we drew the right triangle in, the x value would be negative 1/2. The y value is square root of 3 over 2. If we skip to the next multiple of 30, the x value is the long leg, so that's negative square root of 3 over 2. The y value is the short leg, which is 1/2. Continuing around the unit circle, our next multiple of 30 degrees is this angle here. The x value is negative square root of 3 over 2 because it is the long leg. The y value is negative 1/2 because it is the short leg. Next, we have this angle here. Our x value is negative 1/2. The y value is negative square root of 3 over 2. Our next angle, our x value is positive 1/2, and the y value is negative square root of 3 over 2. Finally, we have an x value that is the long leg, so square root of 3 over 2, and a y value of the short leg, negative 1/2. Now let's go back and look at the multiples of 45 degrees. So if we look at the triangle in the first quadrant, this is a 45, 45, 90 triangle. We know that the two legs, which are the x and y value, both have a value of square root of 2 over 2. So that is our coordinate point. Similarly, in the second quadrant, we have an x value of negative square root of 2 over 2, a y value positive square root of 2 over 2. In the third quadrant, both are negative. In the fourth quadrant, our x value is positive and our y value is negative. So the x values are the cosine values of that angle, the y values are the sine values of that angle. Let's go back and do the tangent. So I'm going to write the values for tangent in purple. We said earlier that tangent is y over x, so all we need to do is divide the y coordinate by the x coordinate. So if we start at our first angle of 0, 0 divided by 1 is 0, so our tangent value is just 0. Next, you have 1/2 divided by square root of 3 over 2. So you have 1/2 times the reciprocal, which is 2 over square root of 3. This gives us 1 over square root of 3, and if we rationalize the denominator by multiplying by square root of 3 over square root of 3, we get square root of 3 over 3 as our tangent value for this first angle of pi over 6. For the next angle, we have square root of 2 over 2 divided by square root of 2 over 2, which is 1. Then we have square root of 3 over 2 divided by 1/2, or times the reciprocal, which gives us square root of 3. Here we have 1 divided by 0. Since we can't divide by 0, the tangent function is undefined at an angle of pi over 2. If we continue going around the unit circle, we have square root of 3 over 2 divided by negative 1/2, which gives us negative square root of 3. Square root of 2 over 2 divided by negative square root of 2 over 2 is negative 1. 1/2 divided by negative square root of 3 over 2 is negative square root of 3 over 3. 0 divided by negative 1 is 0. Negative 1/2 divided by negative square root of 3 over 2 is square root of 3 over 3. Negative square root of 2 over 2 divided by negative square root of 2 over 2 is 1. Negative square root of 3 over 2 divided by negative 1/2 is square root of 3. Negative 1 divided by 0 is undefined, so the tangent function is also undefined at 3 pi over 2. Continuing, negative square root of 3 over 2 divided by 1/2 is negative square root of 3. Negative square root of 2 over 2 divided by square root of 2 over 2 is negative 1. And lastly, negative 1/2 divided by square root of 3 over 2 is negative square root of 3 over 3. You need to memorize the unit circle, both the angles in degrees and radians, and the coordinate points. You can either choose to memorize the tangent functions, or you can just rederive them by doing y divided by x each time.